Year 11, so if you've done nothing this summer, lock in for this bounds question so you don't lose marks on it in your year 11 mocks. Okay, so in this question we are told that a rectangular swimming pool has a length of 8.4 meters measured to the nearest 0.1 meter. We're told the width is 5.2 meters to the nearest 0.1 meter, and we're told the depth is 2.1 meters to the nearest 0.01 meters. Then we are asked to work out the lower bound and the upper bound for the volume of the swimming pool. Now, the first thing before we even begin answering this question is you have to think about what actually happens when you round something to a particular decimal place. If you're rounding a number to 2 decimal places, you look at the third decimal place to determine whether you round up or down in the second decimal place. For example, if you are rounding 1150 to 2 significant figures, you will look at the 5, which is the third significant figure, and from that you determine that to 2 significant figures the number is going to be 1200. When trying to find the upper and lower bound, you apply the same concept just in reverse. Now we know that 8.4 was rounded to 0.1 meters, so we need to look at the number that would be after the 4 and think what number would that have to be in order to round to be 8.4. In order for the number to round to 8.4 but be on the upper bound, the number after the 4 would have to be 4999999. Why? Because we round when it's less than 5. But in bounds, we write this number to be 8.45 because it makes the calculations easier. Even though technically speaking, it should be 8.449999 instead of 8.45. So applying the same concept to the other numbers, we get that the upper bound of the width is the 5.25. To find out the depth of the pool, you can either do the method that we've just done, or you can try this other method which I'm about to share instead. Here is another way that you can think about bounds if that didn't quite make sense. The 2.1 in this example is known as the measured value, and because it's rounded to 0.01, that's the degree of accuracy. To find the upper and lower bound, half the degree of accuracy and take away half of the degree of accuracy from the measured value. Half of 0.01 is going to be 0.005. 2.1 plus 0.05, as it's the upper bound, is going to give us 2.105. When it comes to finding the lower bound, the same concept applies except from in the other way. So you can either half the degree of accuracy or you can try logic your way to the final answer. For the lower bound, you want the value that you find out to be rounding up to 8.4. So the lowest that it could possibly be is 8.35. And you would have gotten the same answer if you halved 0.1 and took it away from 8.4. Applying this concept, you get the width to be 5.15 and the depth to be 2.095. As we are told to calculate the upper and lower bound for the volume, to find the volume you multiply length times width times depth. So we're going to have to use all of the upper bound values to find the upper bound for the volume and all of the lower bounds to find the lower bounds for the volume. This will not always be the case because sometimes you'll have to divide and multiply, and then you'd have to think, well, do I use the upper bound or do I use the lower bound in order to get the final upper and lower bound for whatever you're trying to find out. Doing that, I get 93.4 to 3 significant figures to be the upper bound for the swimming pool and 90.4 to be the lower bound volume of the swimming pool. This question could be worth up to 5 and 6 marks, so make sure you master it before you do your exams.